Welcome to Ultimate Tutorial. This is a place where you learn with ease and understanding. Today we shall be answering Neco 2024 chemistry practical questions. Alright, welcome to this channel. Today we are going to be answering the Neco examination that was held today, and I'll be explaining the solution to us for those of us that still have issues dealing with quantitative analysis. So the quantitative analysis was based on a titration between tetraoxosulfate 6, that is H2SO4, and sodium trioxocarbonate 4. Okay, so that's the titration that happened, and this is the calculatory aspect of it. Now the question says A is a solution containing 4.40 grams of tetraoxosulfate 6 acid per dm cube of solution. Now when you see a question like this, when you see the mass written 4.40 gram of tetraoxosulfate 6, it is telling you that tetraoxosulfate 6 is the acid, that's the solution, that is A, and the mass of that acid, or A, is 4.40 gram. And this 4.40 gram was actually the mass of the acid, or A, that was measured and dissolved in 1000 cm cube, because 1000 cm cube is equivalent to 1 dm cube. So they had to put this in 1000 cm cube of water to make it a standard solution. All right, so now B is a solution containing 7.50 gram of impure sodium trioxocarbonate 4 per dm cube. So the same thing, the sodium trioxocarbonate 4 here is B. And also another thing to note is that the sodium trioxocarbonate 4 is not a pure sodium trioxocarbonate 4. It is impure. That means some other things were added to the sodium trioxocarbonate 4. We have some other impurities in this sodium trioxocarbonate 4. And so the sodium trioxocarbonate 4 plus the impurity all makes 7.5 grams. So we have 7.50 grams of the impure sodium trioxocarbonate 4 in 1000 cm cube, which is equivalent to 1 dm cube of the solution. Now the question says titrate A against 20 cm cube or 25 cm cube of B. Now most schools we have 20 cm cube pipette, and some other schools we have 25 cm cube pipette. It depends on the pipette that is given to you for titration, all right, in order to suck the B. All right, so if you are using 25 for this particular class, for this purpose, we are going to be using 25 cm cube of B. Now the indicator used is methyl orange, right, full stop. Now repeat the titration 3 more times. The reason why we are doing titration more than once is in order to have an accurate value, an accurate volume of the acid, and so we have to record our result in the table 1.1. Now let's move downward a little. The volume of the pipette used is 25.00 cm cube. That is recorded. You have to record that first. That is needed. Now let's come down a little. The table is given as thus. So from this table you can see that we have our final reading, initial reading, and our volume of acid used. All right, according to the marking scheme, it is expected of every student to write these values in 2 decimal places. All right, now to calculate the average volume of acid used, we are adding the first, the second, and the third titer value, and we divide by 3. We are not including the rough titer. right? The rough titer is not to be included because of impurities, because of some contamination. So the rough titer is not included. So you had 21.20 plus 21.10 plus 21.20 divided by 3. Then we have 21.2 cm cube. This is the volume of acid used. Now from the reaction equation, H2SO4 is reacting with sodium carbonate to give us sodium sulfate plus water plus CO2. Alright, CO2 is released as the gas. So the question says calculate the concentration of A in mole per dm cube. Calculate the concentration of A in mole per dm cube. In order to calculate the concentration of A in mole per dm cube, this formula is required. Alright, concentration of A in mole per dm cube means we need to calculate our molar concentration. So the formula is mass concentration is equal to molar concentration times molar mass. So now our molar mass of A is calculated as follows. 1, that's the atomic mass of hydrogen times 2 because we have 2 hydrogens, and then plus 32 for sulfur, and then we have 16 for oxygen times 4 because we have H2SO4. So 1 times 2 plus 32 plus 16 times 4. So that give us 19 grams per mole. That's the molar mass of A. Now the mass concentration of A has already been given in the question as 4.40 grams per dm cube. So therefore, to make molar concentration the subject of formula, we are going to say molar concentration of A is equal to mass concentration divided by molar mass. Mass concentration is 4.40 grams per dm cube over 98 grams per mole, and that gives us 0.0449 mole per dm cube. Note that your answers should be in at least 3 significant figure. All right, so every of your calculations must have answer within 3 significant figure. The second question says we should calculate the concentration of B in moles per dm cube. Now we already know the concentration of A in moles per dm cube. So to calculate the concentration of B in mole per dm cube, note that this concentration we are about to calculate is the concentration of the pure sodium trioxocarbonate in that impure solution. So anything we get from here is the concentration of the pure solution of sodium trioxocarbonate. So in order to do this, we use CAVA over CBVB is equals to NA over NB. Now CA implies concentration of acid in mole per dm cube, the average volume of acid used, that's VA, the concentration of base in mole per dm cube, the volume of base that was pipetted, or the volume of sodium trioxocarbonate that was pipetted, is equal to the number of mole of acid in the reaction equation, the number of mole of base in the reaction equation. So our CA was calculated to be 0.0449, that's what we have here, times 21.20. Don't forget that was our average titer value, over CB, the concentration of base in mole per dm cube, that's what we are looking for, times 25. 25 is the volume of the pipette that was used to take the sodium trioxocarbonate, equal to 1:1. Now 1:1 is gotten from the reaction equation. Now let's see the reaction equation. So the reaction equation here, we have 1 mole of H2SO4 plus 1 mole of Na2CO3. So that's where we got 1:1 from, 1:1. All right. So therefore, doing that, we make CB subject of formula. Now take note, when you are calculating using this formula, whatsoever parameter you are told to look for, you must show how you made it the subject of formula. All right. Marks are always awarded to change your subject of formula. So CB will be equal to, you cross multiply, all right, that's 0.0449 times 21.20 times 1 divided by 25 times 1. All right, that gives us 0.0381 moles per dm cube. So this is the concentration of the pure Na2CO3. all right. So now the concentration of the base, we have to calculate the concentration of B now in grams per dm cube. Concentration of B in grams per dm cube. So this is telling us to calculate the mass concentration of B. We have calculated earlier in this place the molar concentration of B. So now the mass concentration of B is what is needed. So we go by that formula again. Mass concentration is equals to molar concentration times molar mass. Now our molar concentration is this. That's the pure sodium trioxocarbonate times 106. 106 is the molar mass of sodium trioxocarbonate. Look at it here. Sodium is 23 times 2 plus carbon is 12 plus oxygen is 16 times 3. So when you do that, you get 106 gram per mole. So 106 times 0.0381 will give us 4.038. 3 significant figure, 4.04 grams per dm cube. Unit is very, very important. All right. So last question, okay, second to the last question says we should calculate the mass of the impurity in 1 dm cube of B. Don't forget that the solution given to us for B is an impure solution, but then we have calculated the amount of the pure sodium trioxocarbonate in the impure solution as 0.0381. okay, and the mass conc is 4.04. that's for the pure. Now to get the mass of the impure, we're going to subtract this mass of pure from the mass of the impure. Okay, so we say the mass concentration of the impure solution minus the mass concentration of the pure. Now 7.50 grams per dm cube is the mass of the impure. It is given in the question. Look at it here. They said B is a solution containing 7.50 grams of impure. So the mass of the impure sodium trioxocarbonate is 7.50. So we're going to subtract the pure from this value. So therefore 7.50 grams per dm cube minus 4.04 grams per dm cube will give us 3.46 grams in 1 dm cube. All right, 3.46 grams. That is the mass of impure, all right, in the solution of B. Coming to the last question on quantitative analysis for Neco 2024, it says we should calculate the volume of CO2 released in 1 dm cube of B. Don't forget that when the reaction happened, we had a release of carbon dioxide as a gas. Now we are to calculate the volume of this gas that was released, that evolved. Now what we are going to do is to compare the B. We are comparing the B and the gas. So since in this reaction equation, look at the reaction equation, we have 1 mole here and we have 1 mole here. It's not written there, but it is 1 mole. So 1 mole of Na2CO3 is equivalent to 1 mole of CO2 from this reaction equation. 1 mole of this produced 1 mole of this. So if 1 mole of Na2CO3 gave us 1 mole of CO2, all right, and we already calculated the mole of the pure Na2CO3 as 0.0381. You remember that was the mole of the pure. So since 1 mole is equals to 1 mole of this, that means 0.0381 mole of this would also be equivalent to 0.0381 of CO2. That is by equivalence because it is both the same mole, right? So that means that the mole of CO2 gas released is 0.0381. So therefore, how can we now change or convert this mole to volume? There is a relationship that says mole is equals to reacting volume. In this case, it's going to be the produced volume, right? The produced volume over the molar volume. So to calculate the produced volume now of CO2, it's going to be
mole times molar mass. You cross multiply mole times molar mass. The mole again 0.0381. That's the mole of CO2 produced, which is equivalent to the mole of the pure Na2CO3 times the molar volume. The molar volume is 22.4 dm cube. 1 mole of any gas is equals to 22.4 dm cube. All right, so multiply this, you have 0.853 dm cube at STP. STP means standard temperature and pressure. Don't forget, it should be in 3 significant figure. So that is the end of the quantitative analysis question from Neco 2024. It's quite easy and simple and direct for students to understand. Alright, thank you for joining this channel. If you have not subscribed, please kindly click on the subscription button and notifications will be sent across to you. If you have any comments and questions, please drop your comment below and I would answer adequately. Thank you once again.